Welcome to Ask and Learn.
A signal is described by the function dt equals to c e to the power t by tau. We have to calculate the Fourier transform for this function, that is a omega, and sketch and interpret the results. And for B part, how are dt and a omega are affected by the change in tau. First, for transform, the formula we will be using is ak is 1 by 2 pi integration from minus infinity to plus infinity f of x e to the power minus ikx dx. Here the function is a omega equals to 1 by 2 pi from minus infinity to plus infinity c e to the power minus t by tau e to the power minus I omega t. This is equals to c by 2 pi, c taking outside of the integration from minus infinity to plus infinity e to the power minus t by tau. E to the power minus omega t can be written as cos of omega t minus I sin omega t. Opening the bracket and multiplying by the exponent e by 2 pi, the integration from minus infinity to plus infinity e to the power minus t by tau cos omega t minus of integration from minus infinity to plus infinity e to the power minus t by tau sin omega t. This is the imaginary part. Since e to the power minus t by tau is an even function due to symmetry about the y-axis and sine is an odd function, the product of them will be an odd function, and when integrating with between the equal and opposite limits, the result will be 0. So the remaining equation we have is c by integration of minus infinity to plus infinity e to the power minus t by tau cos of omega t. Here cos is an even function and e to the power minus t by tau is also an even function. Their product becomes even, and when integrating between the equal and opposite units, the result will be equal to twice the integral, and integrating between the 0 and the upper limit e to the power minus t by tau cos omega t dt. So on integrating, we have, since that integral doesn't have a closed form solution, we can take it as a equals to 1 by tau and b equals to omega. So the a omega is equals to c by pi integration 0 to infinite e to the power minus cos omega t dt. Then this becomes c by pi 1 by tau divided by 1 by tau whole square plus omega square. On rearranging, this becomes c by pi tau upon 1 plus omega tau whole square. This is the Fourier transform for the given function. After this, the graph representing between c t by pi, this is the 0 and the x-axis represents omega. The graph value of this Fourier transform will represent like this and tends to 0. This higher value gives C tau by pi. There is a continuous spectrum for omega that for every value of omega contributes to the transform but diminishes in the contribution further from 0 to the higher values omega it diminishes. Also, most prevalent value for omega that is part of this spectrum is for omega being 0, at which point the value of transform for omega equals to value, the value of transform is C tau by pi. For B part, when the value of tau gets larger, then dt will get wider, whereas the A omega gets thinner, and then vice versa for being tau smaller also. So the graph for this, the graph between the function fx and time is as follows, and the graph goes on increasing as the time goes up. And if we are going to draw a diagram for the highest value of Ct by pi between omega and function, the graph will be like this, will be very smooth and approaching to 0. And the time will be decreasing this way, tau equals to 2. And if we will plot a diagram between amplitude or the Fourier transformation and the wave number, the graph will be this way. The highest will be at pi, and in the successive 2 pi, 3 pi, 4 pi, it will be 0 transformation.